In these next examples, numbers 5 through 8, we will be concentrating on multiplying and dividing rational expressions. Before we can cancel, we need to make sure everything is factored. So in number 5, the only expression that can be factored is a squared minus 4. Notice there's two terms and they are both perfect squares with a minus sign. So that's a difference of two squares. When you see that, you should be able to factor easily into the square root of a squared is a, and the square root of 4, which is 2 and 2. And since we need a middle term to cancel, we need them to add to a 0, which have to be opposite signs. Over a plus 2 over 3a, nothing else can be factored. So remember, a plus 2 is one whole factor, so we can put that in parentheses if we want to. The a plus 2 and the a plus 2's cancel, because in fractions you may cancel diagonally or up and down. Notice this 3a and the 3a squared can cancel. The 3's go into each other, so we can cancel those. And the a squared and the a can cancel. The a is gone. A squared just becomes a. So everything in the denominator has canceled out. The only thing we have left is a times a minus 2. In number 6, we have a division, and when you divide fractions, you have to flip the division sign to a multiplication sign and multiply by the reciprocal. So we're going to have y squared plus 2y over 6y times 3y squared over y squared minus 4. Now we follow the same rules that we did in number 5, so we must factor first. So we look for every expression that can be factored in the numerator and the denominator. This first one we can factor out a y. GCF is y. So if you divide out a y, you're going to end up with y plus 2 over 6y. The 3y squared cannot be factored, but we have a difference of two squares in y squared minus 4. So again, we can factor that to y minus 2 and y plus 2. Now we can look for common factors. The y plus 2's cancel. I can cancel out the y's. And the 6 will become a 2 when you divide it by the 3, which becomes a 1. Now everything's canceled out of the numerator except for the y squared. The denominator has the 2 and the y minus 2 left, and we can just multiply those together like that, and we are finished with that problem. Okay, going on to number 7. Looks like we have to factor. Well, we could factor the x squared plus 3x plus 8, but if you notice, these two expressions are exactly the same. So we can just go ahead and cancel those out since they are exactly the same on the numerator and the denominator. So what we have left is 2x minus 2 over 4x minus 4, which can be then factored. We can take out a 2 in the numerator, and we have left x minus 1, the GCF is 2. Take out the GCF out of the denominator, which is 4, because 4 goes into both of those expressions. So we're left with an x minus 1. The x minus 1's cancel. We're left with 2/4, which reduces down to 1 over 2. In number 8, the x minus 5 cannot be factored. The 10x minus 2, we can take the GCF out, which is 2. We'll be left with 5x minus 1. Over here, we can FOIL factor, undo the FOIL. X and x, we need two factors of 25 that add to negative 10. That has to be both negative to multiply to a positive and add to a negative. So the factors are 5 and 5, because 5 times 5 is 25, and negative 5 minus 5 is negative 10. The numerator can now be factored. This is two terms, but we have a difference of two squares. We have a perfect square here and a perfect square here. So 5x minus 1 plus 1. Now we can just cancel out any factors that are the same in the numerator and the denominator. So we have a 5x minus 1 that can cancel. We have an x minus 5 that can cancel. And that's it. So the numerator has left in it 5x plus 1, and the denominator has a 2 times x minus 5 remaining. So that's the simplified answer for number 8.